Meghna Parikh and today we are start a Laplace transform lecture number 2. In last lecture we are refer a basic formation proof and basic formula of the Laplace transform, some elementary functions. Now today we are use those elementary functions formula in the example. So we are using definition and direct formula of the Laplace transform. Start. Laplace transform. First of all, we are again refer a definition of the Laplace transform. We are applying Laplace on the f of t. We get 0 to infinite e raised to minus st f of t dt. Okay. So f of t function is, we are applying as a Laplace to t, we are getting as an answer formation as a f of s. Now find the Laplace transform on this interval using definition. Okay, now what is the definition? Definition of Laplace of f of t is said 0 to infinite e raised to minus st f of t dt. Okay. Now, what is here function? Function say that there is a two type of the interval 0 to pi plus pi to infinity e raised to minus st. For the 0 to pi function is 0. For pi to infinity function is sin t dt. Okay. So this interval is 0. We are calculate now only this interval. So what is the interval? Interval says pi to infinite e raised to minus st sin t dt. Okay. Now formula of the e raised to minus st sin t is e raised to minus st upon s square plus 1 minus s sin t minus cos t. Sorry, it is pi to infinite. For the upper limit minus lower limit, we get minus e raised to minus pi s upon s square plus 1 minus sin pi is 0 minus cos pi. Cos pi is 1 minus 1. So answer is minus e raised to minus pi s upon s square plus 1 of this example. Okay. Again, see, Laplace of f of t 0 to infinite e raised to minus st f of t dt. Okay. We are divide this interval in this type of this formation. One is 0 to pi, second one is pi to infinite. In the 0 to pi, a function is 0. In the pi to infinite, function is sin dt. So this interval is 0. This interval is 0. We are calculate only this interval. Okay. So what is interval? Interval is pi to infinite e raised to minus st sin t dt. E raised to minus st upon s square plus 1 minus s sin t minus cos t. This is a formula as a e raised to ax bx. Integration of e raised to ax sin bx formula. We are applying integration of the e raised to ax and sin bx. So it is e raised to minus sin t upon s square plus 1 minus s sin t minus cos t pi to infinite. For the upper limit due to infinity it is 0 minus lower limit e raised to minus pi s upon s square plus 1 minus s sin pi. Sin pi is 0 minus cos pi. What is cos pi? Cos pi is 1. Sorry, it's a minus 1. So it is minus minus plus 1 and this minus. So we getting minus e raised to minus pi s upon s square plus 1 as the answer. Okay, clear? Now next example. Find Laplace transform of the 4t square plus e raised to 2t. Now we are applying Laplace for 4t square plus e raised to 2t. 4 as a constant, Laplace of t square plus Laplace of e raised to 2t. 4. What is a t square? T square is a n factorial. So it is 2 factorial upon s 2 plus 1. Laplace of e raised to t, it is 1 upon s minus 2. A formula of Laplace of t raised to n is n factorial upon s raised to n plus 1. Okay, so what is here n? N is 2. So we are taking 2 factorial upon s square plus 1. And what is the formula of e raised to 8t? 8t is 1 upon s minus a. So this is the basic formula in we are studying about last lectures. So 4 into 2 factorial upon s square plus 1, so it is s cube plus 1 upon s minus 2. So it is 4 to the 8 upon s cube plus 1 upon s minus 2. Taking LCM, it is 8s minus 16 plus s cube upon s cube into s minus 2 is the answer. Okay. Find the Laplace transform of the sin square t. Laplace of sin square t. Laplace is not applicable for the square function. So we are using here a trigonometry formation of the sin square t. What is the trigonometry function of the sin square t? It is 1 minus cos 2t by 2. So 1 by 2 Laplace of 1 minus cos 2t. Okay. 1 by 2. What is Laplace of 1? 1 is 1 by s. Cos 2t is s upon s square plus 4. Because Laplace of cos 2t, cos at is s upon s square plus a square, where a equal to here 2. So s upon s square plus 4. Taking LCM, 1 by 2 s square plus 4 minus s square upon s square, s into s square plus 4. Okay. So answer is 1 by 2 or 2 upon s into s square plus 4. Due to this s square is cut, we are getting only 2 in the denominator. Sorry, in the numerator. So 2 upon s into s square plus 4. Thank you.